So in the previous class, we have discussed about the tension splice. Okay. So what is the tension splice and what is the design of tension splice includes? Okay, that we have discussed. So mainly design of tension splice includes the deciding the thickness of splice plate and deciding the number of bolts or what is the length of weld we have to provided that we have to decide in order to design a tension splice. Okay, so in the connection we may use bolted connection or welded connection. Okay, so if we use bolted connection, we have to decide number of bolts we have to provide. If we use welded connection, what is the length of weld we have to provide, that we have to design. Okay, that we have to design, and that is the first thing we have to design. And the second thing is thickness of splice plate. Okay, so in the designing of splice plate, these two will be included. So up to the design of connection we have discussed in the previous class, and we have checked whether that connection is good for strength in tension. Okay, whether it is good in yield strength, yielding of area, and whether it is good for good against the rupture, good against the block shear. All these we have checked, and the connection we have provided is good against both all these three. Okay, so now we have to decide the thickness of splice plate. Okay, thickness of splice plate. So in order to design the thickness of splice plate, first let us assume that thickness of splice plate is T. Thickness of splice plate is T. Now we already discussed that thickness strength of this splice plate or strength of the connection will be equal to the design strength. Okay, what is the strength imposed on the on that members? Okay, so that will be strength of the connection or strength of this splice plate will be must be equal to design strength. Okay, that we have discussed. So now thickness of splice plate will depend on design strength of splice plate. So first assume that TDN is the design strength of splice plate for assumed thickness of T. Okay, so first we are assuming what is the design strength of splice plate as TDN. Okay, TD is equals to 0.9 AN/FU by gamma ml. So ఇక్కడ ఏంటి మనం thickness find out చేయాలి. ఇక్కడ first we have to find out the thickness, but we don't know the thickness. Okay, so we are assuming the load coming on to that splice plate. Load ఎంత వస్తుంది splice plate మీదకి, that we are first deciding, and based on that load we are deciding the thickness of the splice plate. Okay, so what is the load that is coming onto the splice plate is nothing but TDN. Okay, TDN is equals to 0.9 AN/FU by gamma ml. Okay, and you know how to calculate the net area. Okay, 0.9 into 410. So FU is the 410 and AN is equals to 300 minus 3 into 22. Okay, because what is this TDN means? Strength against the rupture of the plate. So rupture తీసుకున్నప్పుడు which section we will consider? Critical section. Okay, we have to consider the critical section. And how many bolts in the critical section? 3 bolts in the critical section are there. Okay, so we have to net area kabatti we have to deduct all these 3 holes. Okay, so 3 into 22 multiplied by area means breadth into thickness. Okay, breadth into thickness. So breadth is equals to 300 minus 3 into 22 is due to the deduction because we are calculating the net area. Okay, 3 is number of bolts in the critical section and 22 is diameter of the hole. Okay, that is what we are deducting from the total breadth. Okay, and T is the thickness of splice plate here because we are calculating the thickness of splice plate. Splice plate strength వచ్చేసి TDN గా తీసుకున్నాం కాబట్టి, so T is the thickness of splice plate here, and we are providing not a single splice plate, we are providing the 2 splice plate. One is on top and one is on bottom. That is nothing but double cover lap joint. Okay, so here is one splice plate and here is another splice plate. So the thickness is equal, thickness of splice plate multiplied by 2. If 2 splice plate kuda how much strength it has to carry? TDN strength has to be carried by these two splice plates. Okay, so T into divided by gamma ml is 1.25. Okay, so if you calculate this, you will get TDN as 173,577.60 newtons. Okay, now we calculated the what is the strength coming onto the splice plate. Okay, so we have another criteria. We have another criteria that, see, 0 greater force we have to consider 0.3 into TGD or sorry TDG or T, which is the greater force that we have to consider as the strength of the splice plate. Okay, so sorry, TDG already we have calculated, so 0.3 multiplied by TDG, just TDG, you can get 20,4545.4 newtons, and T is the tension force coming onto the connection, that is nothing but 500 kilonewtons or 500 kilonewtons. So which is the greater value among these two, that we have to consider as the strength of the splice plate. Okay, so which one is greater among these? Tension force coming onto the connection, that is the greater force, that is nothing but 500 kilonewtons. Okay, so now make these two values equal, TDN value and this value, what is the strength to be provided to the splice plate. Okay, let us equalize these two value and extract T from this, so that you can get T is equals to 2.88 mm. 2.88 provide cheyalem kabatti we can increase it. You don't have to decrease it. Okay, increase aina cheyochu kani decrease matram cheyavu. Okay, minimum 2.88 we have to provide. So I am rounding it off to 3 mm. Okay, so what is the thickness of this splice plate? 3 mm. Thickness of this splice plate we have to provide is 3 mm. Okay, so this is how we will decide the thickness of the splice plate. Okay, what is the design of a splice plate? Includes design of connection and design of splice thickness. Okay, so design of connection, you know how to design the bolted connection. If you want to design welded connection also, you know how to decide the welded connection. Okay, and this is about the, this is how we can decide the thickness of the splice plate. Okay, so after finding all these values, okay, what are the number of bolts and what is the thickness of the splice plate, after that you have to give the clear diagram of all these dimensions. Okay, what is the thickness of first plate, what is the thickness of second plate? So thickness of first plate is 20 mm, thickness of second plate is 10 mm, and thickness of packing plate is 10 mm. Okay, so this is we have decided that the 6 bolts we have to provide, right? Only one plate we have considered, not both the plates. Both the plates consider chesi kaadu manam design chesi, only one side plate maatrame consider chesi design chesam. So 6 bolts on one half of the connection. So this is how we are making the arrangement. Okay, and this is also we have assumed what is the end distance, pitch distance we have assumed. Okay, and thickness of splice plate we got 3 mm. So all the details you have to give in the diagram at the end. Okay, in any design you will do. Okay, you have to, at last you have to give this diagram, clear diagram of all the dimensions and details of provision of bolts or welded connection. Okay, so this is about the splice plates. Okay, and our next topic is about Okay. Our next topic is about log angle. Okay. So this log angle is see, in order to reduce the length of the connection, we will provide these log angles. Okay. So suppose if you want to connect two or more members. Okay. If you want to connect two or more members, what is the common portion that we are using to connect two or more members? A gusset plate we will use like this. Okay. Gusset plate will be used to connect the members, two or more members. Okay. Sometimes incoming load will be more on the members. Incoming load will be more on the members. So in order to provide the strength for the incoming load, we need to provide more number of poles. We need to provide the more number of poles for a connection. So provision of more number of poles for a connection leads to the increase in the common portion of gusset plate and the main angle. Okay, more number of poles provide cheyali ante we have to increase the overlap of main angle and gusset plate. The overlap length will be more. Okay, if overlap length will be increased, length of the gusset plate will also be increased. Okay, if length of the gusset plate is increased, what happens? It is not economical because we have to provide more large number. Area of the gusset plate we have to provide will be more. Okay, so it will be not economical because material consumption is more. So in that cases, what we are doing is avoiding the gusset plate, avoiding the increase in the area of gusset plate by providing the extra angle like this. So length of the connection, number of bolts provide చేయడం మాత్రమే ఉంటుంది. So కానీ but ఇంత length లో మీరు ఎన్ని bolts provide చేయాలి అనేది మాత్రం not compulsory. So what we are doing, we are providing another angle section adjacent to the main angle. We are providing another angle section and distributing the bolts to the angle section like this. Okay, so bolts anni kuda oke length lo ila provide cheseyakunda we are distributing all these bolts to half here and half to the another angle. Okay, so what happens then? The length will not be increased, but the connection provided will be same as the previous one. మనం ఎంత వరకు అయితే ఎన్ని బోల్ట్స్ అయితే ప్రొవైడ్ చేస్తామో అన్ని బోల్ట్స్ ప్రొవైడ్ చేస్తాం కానీ గస్సెట్ ప్లేట్ లెంత్ మాత్రం ఇంక్రీజ్ అవ్వదు. Then it will be economical, right? So the extra angle that we are providing, is known as lug angle. Okay, the extra angle which we are providing to avoid the increase in the length of the gusset plate, that is known as lug angle. Okay, so this is mainly used in the previous days. Nowadays it is also mostly avoiding because even though we use the lug angle, we have to make more holes to the gusset plate within the less area. Area of gusset plate we are not increasing it, but we are making more holes to provide the bolts. So what happens? Net area will be much more decreased. Net area of the gusset plate will be much more decreased. So it is also not using. For that also we are not using these days this type of connection lug angle by using the lug angle. Okay, so see, these are the main things we have to remember in the lug angle: gusset plate, main member angle, and lug angle. So figure A shows when you use only gusset plate and main member. Okay, so when you use gusset plate and main member, the length of the connection will be more. Okay, figure B shows Figure B shows, please wait. So figure B shows when we use the lug angle, what is the change? Okay. So this is how the lug angle works. So design of the lug angle increases is design of the lug angle includes how we have to provide the connection and which type of lug angle we have to use. If you are using angle means angle section means it has some dimensions. Okay, angles, what is the length of the legs? Okay, if you are using angle section means, okay, so that we have to decide which section we have to use for lug angle and what is the number of bolts we have to use for the connecting lug angles. Okay, design of lug angle includes all these. Okay, and see points we have to remember while designing the lug angles. Okay, so see the effective connection of lug angle shall as far as possible terminate at the end of the member. Okay, so how we have to connect the lug angle? It has to terminate at the end of the member. Means see, suppose this is the main member and this is the gusset plate. Okay, the lug angle we have to use is have to terminate at the end of the main member. Means here we don't have to provide more than the main member. Okay, and here at least out of the gusset plate we have to provide some length of the lug angle. Okay, but in the overlap of gusset plate and the lug angle, the extra length of the lug angle will not be provided. Okay, and second point is the connection of lug angle to main member shall preferably start in advance of the member to the gusset plate. Means the second point shows that, tells that we have to start the lug angle before starting the gusset plate. Means this is the gusset plate, this is the main angle. So ikkada gusset plate start avutunte ikkade lug angle manam start cheyaలి, koncham munde start cheyali. Kakapothe in advance we have to start, but at the ending we have to end with the main member only. Okay, all the first point and second point tells that. Okay, and the third point we have to remember is minimum of 2 bolts, rivets or equivalent welds be used for attaching lug angle to the gusset plate. Okay, so while making the connection to lug angle to the gusset plate, minimum of 2 bolts or rivets or equivalent weld means minimum weld length will be provided. Okay, so if 1 bolt is provided or 1 rivet is provided, we cannot then it is not a fixed connection. Okay, if 1 bolt or 1 rivet is provided, it is not a fixed connection, it will rotate. If 2 bolts, more than 2 bolts will be provided, then it is a fixed connection. Okay, so more than 2 bolts or rivets will be provided to connect the lug angle and the gusset plate. Okay, and the fourth point, if the main member is an angle section. Okay, so always see gusset plate main member is an angle section. So this is the gusset plate, and for this we are connecting a main member like this, and this is a angle section. This is a angle section. If it is a angle section, what are the points we have to remember? Let us see. The whole area of member shall be taken as effective rather than net effective section. Okay, so see this point you will understand while doing the problems. And see the second point, the strength of lug angles and fasteners connecting lug angle to gusset plate should be at least 20% more than the force in connecting leg. Okay, so now while connecting these lug angles, there will be 3 types of connections. Okay, one is first we have to make connection for main member to the gusset plate. Main member ki gusset plate ki ఒక కనెక్షన్ మేడ్ చేయాలి. తర్వాత నెక్స్ట్ లగ్ యాంగిల్ టు ది మెయిన్ మెంబర్ వి హ్యావ్ టు మేడ్ ఏ కనెక్షన్. లగ్ యాంగిల్ కి main member ki we have to made a connection, and the third connection we have to made is to lug angle and the gusset plate. To lug angle and the gusset plate. Oka member ki interconnected undali, lekapothe stable ga untunda undadu. Okay, so while making these connections we have to make sure that strength of the lug angles and fasteners connecting lug angle to the gusset plate should be at least 20% more than the force in connecting leg. So what is the force what is the force coming to the lug angle? So more 20% more force we have to consider while designing for the connections. Okay, so వచ్చే లోడ్ కన్నా 20% ఎక్కువ కన్సిడర్ చేయాలి మనం. Okay, and next point is the strength of fastener connecting lug angle and main member shall be at least 40% more than the force carried by the outstanding leg. So this point is while connecting the lug angle and the gusset plate. While connecting lug angle and the gusset plate, for that connection we have to consider 20% more. But while connecting lug angle and the main member, we have to consider 40% more than the force carried by the outstanding leg. Okay, three types of connections in Japan. One is, first connection is from main member to the gusset plate. Second connection is main member to lug angle. And the third connection is lug angle to gusset plate. Ee mood connections chestam. So e connection, all of these three connections, among all these three, if you are connecting lug angle and the gusset plate, for that connection you have to consider 20% more force than the coming force. Okay, and while connecting lug angle and the main member, you have to consider 40% more force than the upcoming force. Upcoming force kana 40% more you have to consider. Okay, and the fifth point you have to remember is in case of main member is a channel. So fourth point is when the main member is a angle section. Okay, and the fifth point is when the main member is a channel section. Okay, if it is a channel section, the strength of fasteners connecting lug angle to the gusset plate should be at least 10% more than the force, and the strength of fasteners connecting lug angle and main member will be 20%. Ikkada 20 and 40%, ikkada 10 and 20% if the main angle is a channel section. Okay, these are the points you have to remember before going to the design of the lug angle. Okay, so what is the lug angle, ma? In order to decrease the length of the connection between gusset plate and the main member, we are introducing the lug angle. Okay, in order to decrease the length of the connection, we are introducing the lug angle. And the lug angle, we will make three types of connection. In those three types of connections, when we use different types of sections, what is the strength we have to consider? All that we have discussed. Okay, now let us see an example. A tension member of a roof truss carries a factored axial tension of 430 kilonewtons. Design the section and its connection without using lug angle and using lug angle. So in the first case, you have to design the section without using lug angle, and in the second case, you have to design the section using lug angle. Okay. So design of tension member without lug angle means you will design as usual as a tension member. Tension member ela design chestamo idi kuda alage. Okay, but here first we have to select the angle section that we are providing for a lug angle. Okay, and what is the given data? Tensile force in member, that is equals to 430 kilonewtons. And let us consider the strength in yield is tensile force in member. Okay, so we are considering the strength in yield as tensile force in member, because we have to first select the what is the angle to be provided as a lug. Okay, So for that we are considering the strength of the yield is tensile force in the member. So then gross area required is given by, so what is the gross area? TDN is TDC is equals to AZ into FU by gamma MB. Okay, so tensile force in member is 430 kilonewtons. If you are converting it into the newtons, 430 into 1000, that is equals to AZ into 250 divided by 1.1. And from this you can get AG is equals to 1892 mm square. AG వచ్చేసింది. Means from this AG what you can understand, you have to provide the area of lag angle as 1892 mm square. Have to provide the area of lag angle as 1892 mm square. Then only it will be, then only the upcoming force will be, then only the lag angle will be given strength for the upcoming force. Okay, so we got the area. So based on this area, you have to choose a angle section from the steel tables. Okay, steel tables open cheyandi. I mean code book lone ending lo kuda angle sections unnai kada. So open that and select an angle section which is equal to the area of this. Okay, so equal area ante undakochu, but more area you nearly equal you have to consider, but not less than 1892 mm. 1892 mm square kena takku undadu, more aina undachu. Okay, 1892 ki near ga edi unte that we will consider as the, that section we will consider as the lag angle. Okay, so after seeing the tables I got that ISA 100 10 mm. Okay, which has the gross area of 1903 mm square, which is more than 1892 mm square. 1892 mm square unna angle section edu ledu. So I got the angle section with the area of 1903 mm square. Okay, 1903 mm square, and that angle is 100 into 100 10 mm. Ante leg of length of legs is 100 mm, 100 mm, and thickness of the legs or thickness of the section member is 10 mm. Okay, so this member I am choosing, and assuming that I am using the 20 mm diameter black bolts. Okay, 20 mm diameter black bolts use chestunna. Okay,